Hello, this is the Algebra 2 Unit 1 practice test, basically the review for your Unit 1 test next class. Number 1 wants us to solve for p in the expression or equation. So the first thing I would do is distribute to remove any and all parentheses throughout the problem. So first I would distribute a -2, so that would give me a -6p. Then I would distribute multiply -2 with -6, so that's a +12. Then I'm going to distribute +4 to 5, so that's a +20p. A +4 to a -8, which would give me a -32. Bring down my equal sign. On the other side, distribute this 2, so that's 4p plus 6. And then bring down the +4. I then would combine like terms that are on the same sides. First, I'm going to combine -6p with 20p, and I get 14p. I then want to combine 12 with -32 to get a -20. Bring down my equal sign. On this side, I want to combine 6 with 4, so bring 4p down, and then it's +10. I now want to get like terms on the same side of the equal sign. So I want to move 4p by subtracting. That gives me 10p minus 20 equals 10. I then will need to add 20 to the other side in itself so that 10p will be by itself on the left hand side. So 10p is equal to 30, and then you divide by 10 on both sides to isolate p, and p is equal to 3. Of course, please go back and plug p is equal to 3 in for every single p to double check that the answer is correct. Always check your work. For number 2, we have an absolute value equation. Remember, my strategy is to draw a box around the absolute value bars. All right, and then the first thing you must ask yourself is my box alone? And the answer to this is no, my box is not by itself on that side of the equal sign. There's a 5 trying to multiply with my box, and there's a 2 trying to divide the stuff in my box. So until I get my box by itself, I cannot do the 2 different equation setups. So the first thing I'm going to do is I have choices, of course. So there's not only one right way, but I want to multiply by 2 over 1, which is my denominator right here on both sides to get the 2 to remove from the left. In doing so, I will have 5 times the absolute value of g plus 6 is equal to 40. As you notice, my absolute value is still not by itself because of that 5. So now I would divide both sides by 5 to get rid of that 5 from in front, which would leave me with the absolute value of g plus 6 is equal to 8. Now that my absolute value box is isolated, I can now set up my 2 tracks. All right, and remember there's always a positive and negative track, or original versus opposite track, depending on how you want to look at it. So we'll do the positive track first, which is take the contents out the box. So g plus 6 equals the original, so 8. And then the opposite or negative track, take the contents out the box, g plus 6, and it equals negative 8. Now isolate g in both expressions. So I would subtract 6 on both sides, which would give me g is equal to 2 for this one. Again, I would subtract 6 on the negative track as well, which would give me g is equal to negative 14. And now, again, you must always check your work because there might be extraneous solutions. You should always check your work with the original equation. The original equation had said 5 times g, the absolute value of g plus 6 divided by 2 is equal to, what was it, 20, I believe. All right, so now we're going to replace g with both 2 first and then negative 14. So with 2, I would have 2 plus 6, which is 8. The absolute value of 8 is 8. So now it's 5 times 8, which is 40. And then 40 divided by 2 is 20. So we definitely know that 2 is a solution. You would repeat the process where you're testing to see if negative 14 is a solution. All right, negative 14 plus 6 is negative 8. So that's 5 times the absolute value of negative 8 divided by 2 should equal 20. The absolute value of negative 8 is positive 8. 5 times 8 again is 40 divided by 2 is 20. So this checks out as well. So you could write your answers as 2 comma negative 14 in a swirly brace, or just say g is 2 or negative 14. For number 3, we have another absolute value equation. Again, I highly recommend you draw a box around it. And then first ask yourself, is the box alone on that side? And no is the answer to that question because of the negative sign in front. So you would have to divide by -1 with everything. And when you divide by -1 with everything, you should know that every sign will change. So that means it would result in a -4y plus 10. Sorry, rewind. -4y minus 10 is equal to the absolute value of 2y plus 4. Okay. And again, once it's isolated, the absolute value box, then you start your 2 tracks. And it doesn't matter if the absolute value box is on the left hand side or the right hand side. That is totally fine. If you want to flip it around, you're welcome to, but you don't have to. So the track 1 is always the original or positive track. So that's -4y minus 10 equals 2y plus 4. Then we have our negative or opposite track. So that's positive 4y plus 10 equals 2y plus 4. Again, I kept the contents of the box exactly the same in both cases. It just happens to be on the right hand side, which is fine. And again, if you don't like how it's structured because you're so used to your box always being on the left, then put your box on the left. That is totally fine. It is okay for you to simply flip this around on each side. Now we solve. So I'm not going to show as many details as I did in the past 2 problems because, again, we've practiced this a couple of times. So please listen carefully to the explanation. So on this side, the first thing I would do is add 4y to both itself and to 2y. When I add 4y, I'm left with a -10 equals 6y plus 4. I then would subtract 4 from the right hand side as well as -10, which would give me a -14 is equal to 6y. I then would divide both sides by 6, which would give me a -14 over 6 is equal to y. I then would need to reduce because both of those numbers are even, 14 and 6. So they're divisible by 2. So when I divide 14 by 2, I'm going to get a -7. When I divide 6 by 2, I'll get a 3. So in its simplest form, the equation is equal to -7 over 3. On the opposite track, we have, I would subtract 2y from both sides, which would leave me with 2y plus 10 equals 4. I then would subtract 10 from both sides, which leaves me with 2y equals -6. And then divide by 2, so y is equal to -3. And now we have to check our work with the original problem. So there's a fraction involved, folks, so let's get started. The original problem was 4y plus 10 equals negative absolute value of 2y plus 4. Okie doke. So now I'm first going to be replacing y with, I'm going to use negative 3 first, since it's smaller and easier to manipulate. Alright, so on the left, that's 4 times negative 3, which is negative 12. Negative 12 plus 10 is a negative 2. On the right hand side, we have a negative absolute value. And inside the absolute value, we have 2 times negative 3, which is negative 6. Negative 6 plus 4 is negative 2. So bring down the negative 2 on the left. Now the absolute value of negative 2 is positive 2, right? And then we still got to multiply it by the negative sign. So negative 2 equals negative 2 does check out. So this is a solution. Now we check it with the fraction. So you got to remember how to add, subtract with fractions, and to multiply with fractions. So we're using negative 7 over 3. Alright, so we're going to have the sidebar to practice some fraction skills. So if I want to take 4 times negative 7 over 3, I would first make 4 a fraction by putting it over 1. I then would need to multiply the tops together and as well as the bottoms to get a negative 28 over 3. Alright, so now I'm going to add negative 28 over 3 plus 10 over 1. Again, you got to turn it into a fraction, but they have to have common denominators. So I need to make 10 have a denominator of 3 by multiplying with 3 both at the top and at the bottom, which would give me 30 over 3. Now I'm going to take my numerators, which are negative 28, and add it to 30. So my result would be a negative, I'm sorry, 2 over 3. So the left hand side is 2 over 3. Again, if you need assistance with fractions, please come get some help. So we know what the left side equals. It's 2/3. Now we have to focus on the right hand side. So now inside the absolute value, I have 2 times negative 7/3. So again, you put 2 over 1 and multiply the numerator with numerator, denominator with denominator. So that gives me a negative 14 over 3. I then would take negative 14 over 3 and add it with 4 over 1 because is there a plus? Oh, rewind. Yeah, no, I'm right. There's a plus 4 right here in the absolute value. So again, I need to have a denominator of 3. So I multiply top and bottom by 3 to get that. So I would have 12 thirds. So now it's negative 14 plus 12, which is a negative 2 thirds. So that's what's left inside our absolute value. So now bring down the negative sign, take the absolute value of negative 2 thirds, and you're going to get a positive 2 thirds. And then you got to take that negative sign and multiply it to the 2 thirds. So it ends up being 2 thirds equal to negative 2 thirds if done properly. And since both sides do not equal the same thing, this solution doesn't work. So the only solution to this particular absolute value equation is negative 3. Number 4 wants us to write and solve the absolute value equation that can be used to determine the least and greatest optimal temperatures for the following situation. Most freshwater tropical fish thrive if the water is within 5 degrees Fahrenheit of 85 degrees Fahrenheit. So, as we discussed in class, the formula for this particular scenario is the absolute value of x minus c is equal to r. Where c is the central or average value, so sometimes people refer to it as a, and then r is the range of possibilities. So in our particular problem, sorry guys, in our particular problem, 5 is R and 85 is C. So let's put everything in its place. So that would be the absolute value of x minus 85 is equal to 5. Now we're going to solve it so that we can find the least and greatest temperatures, also known as the minimum and maximum temperatures. So again, we have our two tracks. Our positive would be your x minus 85 equals 5. And our negative or opposite, x minus 85 equals negative 5. So I would add 85 to both sides here, which would give me x is equal to 90. I would add 85 to both sides here, which would give me x is equal to 80. So the least value or the minimum value for this is 80. And the maximum value or greatest value is 90. Come on, computer. Alrighty, now let's work out number 5. Sorry, my computer is not cooperating with me right now. So solve and graph the following inequality on a number line. We have 1 over 4 minus 3m over 2 is less than 2 over 3. So remember, if we don't like fractions, we can always get rid of them by taking each of the denominators multiplying them together. So my denominators are 4, 2, and 3. When I multiply those, that's 4 times 2, 8. 8 times 3, 24. Take 24, put it over 1, and multiply it with the entire inequality. So I first multiply it with the first fraction, and again, when you multiply fractions, it's top with top, bottom with bottom, so that would give me a 24 over 4. Bring down your minus sign. Now multiply it with the second term. 3 times 24 is 72 m, and it's over 2. Bring your less than symbol. Now multiply it with the last term, 2/3, which would give me 48 thirds. Now we reduce. So 24 divided by 4 is 6. 72 divided by 2 is 36. Less than 48 divided by 3 is 16. Sorry, I forgot my m. So now we don't have any more fractions, which is awesome, and it makes it easier. So now let's isolate m. First, by subtracting 6 on both sides. So that leaves me with a negative 36m is less than 10 because I subtracted 6. Then I would divide by negative 36. So remember, anytime you multiply or divide by a negative, that affects your inequality symbol. So I'm going to have m by itself, but my inequality symbol flips over because of the negative 36. So m is going to now be greater than 10 over negative 36. But of course, we must reduce that. So I do know they're both even, which means they're divisible by 2. So when I divide 10 by 2, I would get 5. When I divide negative 36 by 2, I would get negative 18. So m is greater than negative 5 over 18. And to graph it, on a number line, draw your number line, I would put 0, and recognize that I'm on the left side of 0 because I'm at negative 5/18. I would need to have a open dot because it is not equal to, it is just greater than, and I shade everything to the right. So that's what it means by solve, which is what I boxed, and graph, which is on the number line. So we're going to take a moment and pause right here and reconvene in just a sec.